First of all, notice that the typical level rod is graduated in decimal feet. You can see here that the fractional parts of a foot are labeled 1 through 9. If this rod were graduated in inches, you would also see the numbers 10 and 11 below the red number 1. We use decimal feet to simplify our computations. The very bottom end of the rod is the zero end. Thus, all measurements we take are heights above the surface on which the rod sits. Now take a close look at the marks on the rod. Each black mark has the same height as each white space. This is very different from a measuring tape. You see, with this system, we take our readings at the edges of the marks and spaces. The regular mark heights make it possible for us to read the rod a few hundred feet away. Now here's an important distinction. The reading we take on this type of level rod is not an elevation. It is merely a vertical distance between our instrument line of sight and the surface on which the rod sits. By taking two rod readings, we can find the difference in elevation between 2 points. In this case, that elevation difference is 1.32 feet. The large red numbers on this level rod are 1 foot apart. Each 1/10 fraction of a foot is marked with a black number. Specifically, the top edge of the long mark at the left edge of each black number marks the 1/10 increment. Look closely and you'll see that each 10th mark has its right end beveled up. That is, the point of the bevel is on the edge corresponding to the 10th of a foot. Let's see a closer view of this portion of the rod. The top edge of this mark is 2.30 feet above the bottom of the rod. See how the point of the bevel falls on this edge? The top edge of this mark is 2.40 feet above the bottom end of the rod. These two marks are 0.10 feet or 1/10 of a foot apart. Now notice here there is another mark that is beveled downward. The bottom or beveled edge reads as 2.35 feet. Halfway between each pair of tenth marks, you'll find a half-tenth mark like this one. A half-tenth equals 0.05 feet or 5/100ths of a foot. Here you can see the upper 5/100ths within any whole tenth of a foot contains 3 black marks and 2 white spaces. Then the lower 5/100ths within the same tenth contain 2 black marks and 3 white spaces. Remember that each black mark and each white space are the same height. That is 1/100th of a foot. Therefore, when we apply this pattern, we get these results. The bottom edge of the first black mark above 2.30 has a reading of 2.31 feet. As that mark is 0.01 feet tall, then the top edge of that same mark reads 2.32 feet. 2.33 feet comes at the bottom edge of the next mark, and 2.34 feet falls at the top edge of that same mark. Thus, 2.35 feet is 1 white space above the 2.34 foot mark. 2.36 through 2.39 feet work in the same way. Now, did you notice a simple pattern here? The reading at the top edge of every black mark ends with an even number. Thus, the reading at the bottom edge of every black mark ends with an odd number. Well, equipped with this new knowledge, let's take a few readings. We'll use the main horizontal crosshair in your instrument. Here, the main crosshair is above the red 4, and below the red 5. Then it is between the black 5 and the black 6. So far, we can say the reading will be between 4.5 feet and 4.6 feet. Now, let's read the hundredths fraction. The crosshair is at the top edge of a black mark. Therefore, the hundredths digit will be an even value. Counting up from the 4.50 foot mark, you can see that the crosshair reading is 4.54 feet. Alternatively, you can see that the crosshair is one white space below the 4.55 foot mark, also giving a 4.54 foot reading. Frequently, the crosshair does not coincide exactly with the edge of a mark, as you can see here. Therefore, we round the reading to the nearest hundredth of a foot, that is, to the nearest edge of a mark. Take a moment to try this reading. Did you get 7.83 feet? The crosshair here is just below the bottom edge of the black mark. The bottom edge of each black mark ends in an odd value, so our reading of 7.83 feet fits this pattern. How about this one? Did you get 9.31 feet? Now what happens when the crosshair evenly splits a white space or a black mark? If we were estimating a value smaller than 1/100th of a foot, we could call this one 1.925 feet. However, for the vast majority of our leveling measurements, we'll round the result to the hundredth of a foot. Most of us learned in our math classes to round 1.925 feet upward to 1.93 feet. This rule, while simple to remember, creates an error when we have to round a series of measurements. Consider this series of 6 measurements. For each measurement, the crosshair exactly bisected a white space or a black mark. Thus, each reading ends in 5. However, such precision is typically unwarranted. So, if we round each value upward, as we've nearly all been taught, then the sum at the bottom of these 6 rounded values is larger than the sum of the unrounded values. Well, this makes sense, doesn't it? Once again, the sum of these 6 rounded values is larger than the sum of the unrounded values. If instead of rounding up, we round each value to the nearest even result, the sum of the rounded values now equals the sum of the unrounded values. Notice that the first value was rounded up, the second was rounded down, the third was rounded up, the fourth was rounded down, and so forth. In the grander view, you'll see that half of the values will get rounded down while the other half will get rounded up. Thus, the effects of rounding in this method cancel out in a large series of leveling measurements. Now remember, this rule only applies when the reading ends in 5. That is, when the crosshair splits 1/100th of a foot in half. For all other conditions, round to the nearest 1/100th. Applying this rule to our previous reading, then, we'll round our result to 1.92 feet.